Hello dear students. From this video onwards, let us see queue data structure, but we are going to build queue using array. In the previous videos, we saw how to build a queue using linked list. And we saw two types of queues, linear queue using linked list and circular queue using linked list. The same linear queue which we build using linked list will now be built using arrays. As you all know, queue is FIFO data structure, first in, first out, because whatever you insert first is always deleted first. All these definitions you are very comfortable with. Let's straight away see how a queue looks like when you implement it using array. Now you can think of a queue like this. Let's say that we have an array of fixed size. Obviously, array always has fixed size. Let us say the size of the array is 5 elements. And indexes are 0, obviously it starts with 0, goes up to 4. Let's name the array as A. And along with this, we have two integer counters. Check my words. We have two integer counters, front and rear. Now this entire unit, this collection, which is array of fixed size and two integer counters, make up a queue. And as you all know, that queue is a data structure. If you are asked what is the use of queue, in one sentence you should say queue is a data structure, so it stores data. Finished. That's it. Period. Queue is meant for storing data. That's it. But then the way in which it stores data is first in, first out. So just imagine this queue, as I have shown over here, contains array front and rear. Now you watch that front is a counter which will always give us the index or the position of the frontmost element in this queue, and rear, as the name suggests, will give us the index or the position of the last element in the queue. As an example, right now you see that there is nothing stored in this array. I mean, even the 0th element of this array is empty. There's nothing in the array. What that means is that this queue is at the moment empty. And how do you then represent an empty queue? What you do is these two counters, front and rear, are initialized as -1, both counters. That means that even the 0th position of this array is not filled. So front and rear both are before this 0th element. Yeah, it is at -1 we are pointing out. So what is empty queue condition? The queue is said to be empty if both the counters front and rear are -1. Actually, it is enough to say that front is -1. Come on, you tell me, if front is -1, what do you understand? That there is nobody standing in the front of the queue, isn't it? So if there is no one standing at the front, then the queue doesn't exist. I mean, the queue is empty. Now just imagine that this queue contains three values: 10, 20, 30. And the values were inserted in that order. First we inserted 10, then we inserted 20, then we inserted 30. Now the situation is that front counter and rear counter won't be -1, obviously. So who is the front person? 10. But where is it stored? At place 0. Check how front does not give us the value stored. It gives us the index of the frontmost element. And a rear element over here is 30. But what is its location? Its location is 2. Hence we say that the queue is having front equal to 0, rear equal to 0, and that's the elements stored in the queue. Okay. What if new person joins this queue? What do you think? If it's a queue, where will the new person go and stand? Obviously, the new person will go and stand behind the person currently standing at rear place. So currently the person standing at rear place element is 30. And if 40 is joining this queue, if 40 joins the queue, then 40 must stand behind 30, isn't it? So 40 is claiming that I have joined last, I will be the rear. Then rear counter can't be 2 anymore, isn't it? Rear should become 3. Because now the end of the queue, rather the rear element of the queue, as you can see, is at third place. What if one more element joins this queue? Check that rear is 3 now. What if 50 wants to join this queue? So 50 should stand behind the current rearmost. So are you watching? 50 should go at fourth position. What that means is rear will now become 4. Come on, because 50 is the new value and it has gone at the rear place. So you please try to understand, whenever a new value gets inserted, that's insert operation we are talking about. Insert operation, then rear always increases by 1 because new element will go at the rearmost place. Isn't it so? See something more interesting about this array implementation. Currently front is 0 and rear is 4. And are you watching that the array is full? I mean, now if 60 wants to join this queue, there is no place for 60 and 60 will be rejected because there is no place, and there will be an error shown by insert function. Insert operation is not going to welcome 60. It's going to give an error, queue overflow. This is overflow error when all the elements allotted for the array are already storing the values. Okay, now think of this queue again. It is storing 10, 20, 30, 40, 50, isn't it? And watch the counters. Counters we have is front is 0 and rear is 4. Now imagine we want to delete a value. That's the operation, delete operation. We want to delete a value. Who should get deleted first? Necessarily that person should get deleted first who has entered the queue first. So in all this scenario, 10 should come out first, isn't it? 10. That should get deleted from the queue. So what we would do if we are deleting 10, it is very easy to see that 20 should become the frontmost, or rather 20 should head the queue. So we do a simple updation over here. If 10 is going out, then 20 becomes frontmost, and where is 20 standing? At first place, isn't it? So front, which was 0, check front was 0, will now become 1. What do you say? Now the queue is from 1 to 4, although element 0 is still there. This element is still there, but logically speaking, it is out. The array location is also there, but we are now logically saying that front is 1 and rear is 4. So the queue is beginning from 20 and ending at 50. So 20 becomes the frontmost. Okay, check it out again. What if we want to delete an element from the queue again? Now the new values of front is 1. As you see, 20 is the frontmost and rear is 4. Now what if you call for delete again? Who is the frontmost? You have to refer this counter front. You say, okay, first element is the frontmost. So 20 is the frontmost. Then 20 should get out of the queue. But if 20 gets out of the queue, then 30 should become the frontmost. And where is 30 standing? 30 is standing at second place. So front should become 2. What did you observe? Every delete operation, whenever you delete an element, front increases by 1. This is what delete is going to do. It's going to say, okay, you're standing at front, you're going out, then whoever is standing behind you will become the new front. So front plus plus will be done. Summary is every insert increases rear and every delete increases front. This is in general how the linear queue using array is implemented. When we come back in the next video, we will see the implementation as written on the left over there. By the way, a few definitions have been written. You can pause the video and check these definitions. But I think using these pictures, these diagrams, you have very well understood what is that we are going to do. Thank you very much.